Hello everyone, in this video I will cover section 5.1. Remember that we already covered section 5.2 and 5.3, so it's going back, but there is a reason for that. So the main topic here is called verifying identities, okay? So to verify identities is one of the most complicated things for people in this class, because you're not really solving a problem. What you're doing is just showing that one side is equal to the other side. So you're going to have the left side and you're going to show that it's equal to the right side, or you show that the right side is equal to the left side. So you are not really solving anything. So mostly you are verifying or proving that one side is equal to the other side. So this is similar to the proofs you did in geometry, but they are obviously just specific to trigonometry. Now, to make life easier, is very important to remember these identities, because technically to verify is just a manipulation of this. Remember that sine is equals to 1 over cosine, which means cosine is equals to 1 over sine. And if you combine these two, you could also say that cosecant times sine is equals to 1, okay? The same applies to this. Cosine theta times secant theta is 1. And obviously tangent theta times cotangent theta is equals to 1. So we will be using these identities. I mean, it could be this, this, or this. The ones that we're going to use a lot are the Pythagorean identities, which we have seen this since the beginning of the class. Remember, you have three of them. Sine squared plus cosine squared is equals to 1. 1 plus tangent squared is equals to secant squared, and 1 plus cotangent squared equals to cosecant squared. Now, it's very important to notice that sometimes you just use this directly, but most of the time you're going to use a slight version of this. For example, if sine squared plus cosine squared is equals to 1, that means that cosine squared is equals to 1 minus sine squared. Or the other way around, you can also say that sine squared is equals to 1 minus cosine squared. And the same thing applies to this. Like if 1 plus tangent squared is equals to secant squared, you could say that tangent squared is equals to secant squared minus 1. Or you could say that secant squared theta minus tangent squared theta is equals to 1. So it takes a bit of time to get used to this, but these are technically the only tools you're gonna be using. This. We also have the quotient identities, which remember tangent is equals to sine over cosine, which means cotangent is cosine over sine. And another trick we're going to use, so note, another trick that is going to be common is to multiply by 1. I will point this out once we get to there. All right, so let's try some problems. So here are the strategies that I already mentioned. So you're going to work on one side and you're going to make sure you get into the other side. So typically you're going to start in the more complicated side and show that it's equals to the simpler side. You're going to use the identities that I just mentioned. Sometimes you have to find the common denominator, which is this is algebra, not necessarily trigonometry. Sometimes you have to factor, and when you are not sure, just change from sine to cosine. But let's see how we do this. So here is the first example, and it's asking you to verify that this is equals to this. Okay, so in this problem, this is the left hand side, and this will be the right hand side. Okay, so we're gonna start in one side and show that it's equals to the other side. And like I say, usually you should start on the more complicated side and show that it's equals to the simpler side. So in this case, on the left hand side, we have tangent theta plus cotangent theta. Okay, so notice that tangent, if we use the quotient identities, is equals to sine theta over cosine theta, and cotangent was equals to cosine theta over sine theta. Okay, so remember that here tangent is the same thing as this, and cotangent is this. Now, since you have a fraction, you have to find the LCD. So we need the LCD. And remember, if you have, for example, 1/2 plus 1/3, the LCD is just 2 times 3. So in our case, the LCD is going to be cosine theta times sine theta. So if you look closely for the first fraction, you already have the cosine, so this is missing the sine, so you multiply by sine over sine, which we're multiplying by 1, which it will be the same thing as multiplying this by 2 and this by 3, because remember you need the same denominator. And then you move to the next one. This is cosine theta over sine theta, and this one is missing cosine, so you multiply by cosine. Now if you simplify the top, so notice that sine times sine will give you sine square, sine square theta, and on the bottom you have cosine theta times sine theta, and in the other side you're going to have now cosine square theta over sine theta cosine theta. So now these two are exactly the same. So when that happens, remember you only write the denominator once. So this will be cosine theta times sine theta. Excuse me. And on the top, you have sine squared plus cosine squared. But remember that sine squared plus cosine squared, this is one of the Pythagorean identities. That's just equals to 1. So you have 1 over cosine theta times sine theta. You can rewrite this as 1 over cosine times 1 over sine. And remember, by the reciprocal identities, 1 over cosine is just secant theta, and 1 over sine is cosecant theta. So therefore, this is the right-hand side, and that's it. So that's how you verify the identity. So again, notice all it took was the use of several identities, the ones I mentioned at the beginning. First, tangent is changed into sine and cosine. Cotangent is changed into cosine over sine. Since this is a fraction, you had to find the LCD. The LCD was cosine theta, sine theta. This is missing the sine. This is missing the cosine. When you multiply, you get sine squared plus cosine squared, which is an identity. It happens to be 1. And here you have cosine sine. So this is 1 over cosine times 1 over sine. And this happens to be the reciprocal identity for secant, and this for cosecant, which is exactly what you have on the right side. And that's it. All right, so let's move to the next example. And here you can go from left to right, which the left looks a little more complicated. So notice that here, since you have cosine on this side and you already have a cosine, it will be very useful to change sine into cosine. So recall, before we do the problem, that sine squared theta plus cosine squared theta is equals to 1. So that's the first trigonometric identity that we've seen multiple times. So notice, therefore, that, and I mentioned this like less than 10 minutes ago, that means that sine squared theta, therefore, is equals to 1 minus cosine squared theta. Okay, so therefore, if we start on the left hand side, so we have sine squared theta minus cosine squared theta, but then we already have that sine squared is equals to just 1 minus cosine squared theta. So therefore this gives you this part. You already have the cosine squared theta, and then you have minus cosine and minus cosine. That will give you 2 cosine squared theta, which is exactly the right hand side, and that's it. All right, so let's try one more. I mean, we actually have like 4 more to try. Okay, so we'll start with the reciprocal identities. So we're going to start on the left-hand side. Remember that, okay, we have secant theta minus cosine theta. So secant, remember, was 1 over cosine theta, and then here you have cosine theta over 1. So then you need to find the LCD, and the LCD of cosine and 1 is just cosine. So therefore, notice that since this one has cosine already, this is the only one you have to multiply by cosine. So we multiply by cosine. Now we have 1 over cosine theta minus cosine squared theta over cosine theta. Once they have the same denominator, you can just add the top and keep the denominator. So this will give you 1 minus cosine squared theta. But again, notice this is the exact same formula I did before, that if sine squared theta plus cosine squared theta is equals to 1, that means that sine squared theta is equals to 1 minus cosine squared theta. So therefore, notice that this is exactly this. So therefore, this is just now sine squared theta over cosine theta, which you can write as sine squared theta over 1 times 1 over cosine theta. But remember, 1 over cosine is the reciprocal identity for secant. So this is secant theta, which is exactly the right-hand side. And that's it. All right, so now let's do a problem where I'm going to go from the right-hand side and show that it's equal to the left-hand side. So on the right-hand side, we have 1 plus cosine x divided by 1 minus cosine x. Okay, so something new that we haven't done. I told you at the beginning actually that one of the tricks is to multiply by 1. But remember, 1 could be anything. Like 1 could be just 2 over 2. It could be sine over sine. It could be a cat over a cat. It could be anything, okay? Anything divided by itself is 1. So for these problems, what we're going to do is, since we want to cancel this, then what we're going to do, this is a typo here. This should be just cosine. Sorry, so it should be just cosine. So I'm going to multiply by the conjugate, which is 1 plus cosine, 1 minus, sorry, not the conjugate, 1 minus cosine x. So it's not a conjugate, and 1 minus cosine x. So notice that this is equals to just 1. So just multiplying just by 1. So therefore, on the top, you have 1 plus cosine x times 1 minus cosine x. And then on the bottom, you have 1 minus cosine x times 1 minus cosine x. If you FOIL, remember what happens when you do this. You have a plus b and a minus b, and then you FOIL. This is a difference squares, and you end up with just a squared minus b squared. You should really just check. That's just algebra. So therefore, on the top, you're going to have just 1 minus cosine squared x, which we already know is just sine squared. We did that before. And on the bottom, notice that you have a minus b times a minus b. You can either expand it and say this is a squared minus 2ab plus b squared. You do FOIL again. Or you can just see this is a perfect square and it's a minus b squared. So in our case, we're going to use the perfect square, and it will be 1 minus cosine x squared, which this already gives you what we have here. But the top, because of the identity, remember, it's just equals to sine square x over 1 minus cosine x squared, which is equals to the left hand side. And that's it. All right, so let's move on to question 5. This question is, or this identity is one that's going to be very useful in calculus 1. So I highly recommend you to just memorize it. And I'm just going to show you that it's true. But this is an identity that will be very useful for you. You memorize it. So let me start again on the left-hand side because it's the most complicated side. And you have 1 minus cosine 2x over 2. So notice that cosine 2x, so notice, this is something that we did last time, that cosine 2x is a double angle formula, and this one was equals to cosine square x minus sine square x, and this was one of the formulas that you can write it in 3 different ways. But for our purpose, this should be good enough. But remember, you can rewrite this in three different ways. That's not true for sine. For sine 2x, you can only write it in one way. Remember that sine 2x was equals to 2 sine x cosine x. But the one we need right now is this one, okay? So therefore, instead of writing that, you say, well, this is equals to cosine square x minus sine square x. So therefore, this gives us this by the double angle formula. And on the bottom, there is not much going on. It's just the number 2. So now notice that this will give you 1 minus cosine square x, and then minus sine, actually plus sine square x, everything divided by 2. Now, this will be now the third time that we use this identity. Remember that 1 minus cosine square, which is the one we used in the previous problem here. Remember this, or this, is equals to just sine square. So therefore, this is going to be still just sine square. So therefore, this will be sine square. So that will be the green part. So sine square plus the other sine square you have divided by 2. So this will give you 2 sine square x, everything divided by 2. The 2's cancel. So this is equals to sine square x, which is equals to the left-hand side. Actually, here we start on the right-hand side, sorry. Right-hand side, and we finish on the left-hand side. All right, so we have one more, so let's try the last problem. All right, so let's go to the last example. And here, okay, let's start on the left-hand side. So we start on the left-hand side. We have the secant x plus 1 over tangent x is equal to the other side, okay? So we're going to do the same trick and multiply by 1. Remember that 1 could be whatever you need. So here, the identity that I'm going for, and so that's what is going to justify what I'm going to do. Remember that, so recall that 1 plus tangent square is equals to secant squares. This was the second trigonometric identity, the Pythagorean identity. So therefore, this means that tangent square is equals to secant square minus 1. And this is what I want, especially since this, you can factor it as secant x minus 1. It's a difference of square times secant x plus 1. So therefore, since I already have the plus 1, I'm going to multiply times the minus 1. And also, that should be obvious because of this part right here. So I'm going to multiply times secant x minus 1, and then secant x minus 1. So therefore, on the top, you're going to have secant square x minus 1. Why? Because this is equals to this. And then on the bottom, you're going to have a tangent x times secant x minus 1. So again, remember, if you multiply these two, this times that, it gives you this because of this. So then on the top, notice that this highlighted part is exactly equal to just tangent square. So therefore, on the top, you have tangent square x, and on the bottom, you have tangent x times secant x minus 1. Okay, so here, notice that you can cancel this with this. Why? Because you have x squared over x. Notice that this gives you just x. So therefore, this is equals to tangent on the top, and on the bottom is just secant x minus 1, which is exactly the right-hand side. And that's it. Now, in this problem, you can also start in the right-hand side, and it should give you the left side, so you should give it a try. But that's it, okay? So now, in conclusion, to verify identities, it requires a systematic approach and a good understanding on the fundamental trig identities, and practice is essential to master this. By that, I mean, if you don't see this at the beginning, you have to multiply by, you can try something else, and eventually, well, you will get there. So for example, look, let's say that you're trying to do this problem and you are not sure what to do. So let's start again. So you could also do this. So you have this, and let's say everything else fails. So what you do is, and this may take longer, but if you are not sure how to proceed, just change everything to sine and cosine. On the top, remember that secant is 1 over cosine. And on the bottom, remember the tangent is sine over cosine. And you can see how things start getting a little more tricky, but if you are not sure, you can always change things to sine and cosine. So now on the top, notice that if you add that, you find the LCD, you'll have 1 plus cosine x over cosine x. And then on the bottom, you'll have sine x over cosine x. Since you are dividing fractions, this is essentially 1 plus cosine x over cosine x times cosine x over sine x. So now this will cancel, and here you have 1 plus cosine x over sine x. As you can see, this still doesn't look anything close to this one. So therefore, from here, you're gonna have to multiply by sine or cosine again. So in this case, you have a lot of choices. From here, you can multiply by 1, for example, 1 minus cosine. You multiply by 1 over cosine. This one will give you 1 minus cosine square x, which we already know is just sine squared, over sine x times 1 minus cosine x. So notice that this will give you sine square x over sine x times 1 minus cosine x. This will cancel this, but this is still not close to that. So therefore, you have to keep multiplying until you get to the answer. So that's why for something like this, it will be easier if you recognize you have to use this identity. Now, if you keep going this way, you eventually get there, but you have to do a few more steps before you get there. All right, so that's it.